All right, let's dive into something I know a lot of you have been thinking about, the evolution of APIs. For decades, one particular style has completely ruled the web. But now, well, new challengers have entered the ring. So the big question is REST's long reign finally over? You see this question everywhere, right? On forums, tech blogs, conference talks. Is REST dead? It's a great headline for sure. It's designed to get a reaction, to get people talking. But here's the thing. The real answer is so much more interesting than a simple yes or no. The king isn't dead, not at all. The kingdom has just gotten a whole lot bigger and way more complex. What we're actually seeing isn't about replacement, it's about specialization. It's about our industry growing up and learning to use the right tool for the right job. So to really get where we're going, we've got to take a quick look at where we've been. For the better part of 2 decades, REST was the undisputed, universal king of the API world. Let's talk about why its incredible simplicity made it the standard for basically everyone. The absolute genius of REST was that it wasn't some brand new, complicated thing we all had to learn. Nope. It was an architectural style built right on the foundation of the web itself, HTTP. It cleverly mapped all the basic things we need to do, create, read, update, delete, directly to the HTTP verbs we already knew and used every day. Plus, it used simple, human-readable JSON, which, trust me, was a total breath of fresh air compared to the clunky XML of older systems. All of this meant the barrier to entry was super low, which led to this massive ecosystem of tools and developers that just cemented its rule for years. But, and there's always a but, right? That same beautiful simplicity, the very thing that made REST so popular, eventually started to cause some serious friction, especially at scale. It created something we can call the convenience penalty. So what exactly is this convenience penalty? Well, it's the price you eventually pay for using a general-purpose tool in a highly specialized world. Think about it. You've got microservices zapping messages back and forth hundreds of times a second, or a slick mobile app that just needs one tiny piece of data to update the screen. In those high-demand situations, REST's biggest strengths suddenly start to look like weaknesses. Now, to really wrap our heads around this, we need a good mental model. The problems with REST weren't happening everywhere in the same way. They were showing up on 2 totally different fronts. And honestly, understanding the difference between north-south and east-west traffic is the key to unlocking this whole topic. The problem basically splits right down the middle. First, you've got your north-south traffic. That's the classic stuff. Communication from a client, like your phone or a web browser, up to your back-end services. Then, you've got east-west traffic. This is all the internal chatter happening between your microservices behind the scenes in your own data center. REST was struggling in both directions, but for completely different reasons. So on that north-south front, the big bottleneck was all about data fetching. With REST, your app might ask for a user's name, but the API endpoint sends back their entire profile. That's overfetching. It just wastes mobile data and kills battery life. Or even worse, to build a single screen, your app might have to make 5, 6, 7 different API calls, one after another. That's underfetching, and it's what makes your app feel slow and, well, just plain clunky. Now let's look at the east-west traffic between services. Here, the problem was more like a performance tax. Your services are constantly taking data structures, turning them into text-based JSON, sending them, and then turning them back. That just chews up CPU cycles. And all those human-readable string keys in every single message, they really add up, bloating your network. And maybe worst of all, there's no machine-enforced contract, so it's way too easy for one team's change to accidentally break another team's service. At scale, this tax becomes incredibly expensive. Okay, so with these really clear problems on 2 distinct fronts, the stage was set for some specialized successors to show up. And again, this isn't about one king replacing another. It's about engineers finally building the right tool for the right job. I absolutely love this analogy because it just perfectly captures the whole situation. You wouldn't use a Formula 1 car to haul lumber, right? And you definitely wouldn't enter a pickup truck in a Grand Prix. GraphQL and gRPC aren't trying to be better pickup trucks than REST. They are precision-engineered race cars for very, very specific tracks. And here is where it all clicks into place. The solutions map directly to the problems. GraphQL was built from the ground up to solve that north-south problem. It gives the client the power to ask for exactly what it needs, which totally eliminates over and underfetching. Meanwhile, gRPC is the specialist for east-west traffic, designed for that blistering, high-speed, low-latency communication you need to completely erase that microservice performance tax. The really crucial thing to get about GraphQL is the mental shift it forces. With REST, you're always thinking about where. Where's the user endpoint? Where's the post endpoint? With GraphQL, you basically hit a single endpoint, and the question completely changes from where is the data to what data do I need and how is it all connected? It's a whole new way of thinking. So here's how it actually works. Your client sends a query that looks almost exactly like the JSON it wants to get back. The server then checks that request against a really strict contract called a schema. If everything looks good, the server uses these little things called resolvers to go out and grab only the data you asked for, and then it sends back a single, perfect JSON response. Nothing more, nothing less. It's incredibly efficient. Okay, let's switch gears and talk about gRPC. Its performance isn't magic. It's just pure physics. It's a full-stack optimization. It combines two key pieces of tech: a super efficient binary message format called protocol buffers, or protobufs for short, and a modern high-performance transport protocol, HTTP/2. Just look at the core difference here. It's night and day. With JSON, you have to literally repeat the text string username in every single message that goes across the wire. Protobufs are way smarter. In a schema file, you define that username is field number 1. Then the actual message just sends the number 1 and the value. This creates a tiny, tiny payload that's unbelievably fast for computers to parse, because comparing numbers is always going to be faster than comparing text strings. Let's just bring it all together for a second. When you see it side by side like this, the different lanes they operate in become crystal clear. Look at the primary use case: REST for general purpose stuff, GraphQL for that north-south data fetching, and gRPC for high-speed east-west communication. Notice the payload, too. REST and GraphQL are usually dealing with text-based JSON, while gRPC is all about that compact binary. And check out the transport. gRPC gets to take advantage of the more modern HTTP/2. It all comes down to their key strength: REST's simplicity, GraphQL's flexibility, and gRPC's raw, unadulterated performance. So, what does this all mean for the big picture? It means we're really entering a new architectural age. We're moving away from just doing what's convenient and moving towards a more mature, principled approach to engineering our systems. And this quote right here just nails the new mindset. The question is no longer what is the best API style, but what is the optimal protocol for this interaction boundary? The whole conversation has matured. We're no longer arguing about finding the one best API. Instead, we're analyzing every single connection point in our system and choosing the absolute best tool for that specific job. This leads us to what we see in so many modern, sophisticated systems today: a polyglot architecture, where all three of these technologies live together in harmony. You might use REST for your public, partner-facing API because, hey, it's simple and everyone understands it. You use GraphQL to power your fast-moving, demanding web and mobile apps. And then you use gRPC for that high-speed internal backbone that connects all your microservices. You get the best of all worlds. Which brings us to our final thought. This whole evolution from a REST monoculture to this new polyglot world of specialized tools, it forces all of us to be better engineers. It forces us to stop and ask a really fundamental question. So forget the hype, forget the trends for just a minute, and think about your own systems. What problems are your APIs truly built to solve? Because the answer to that question will tell you exactly which tool is right for the job. Thanks for